Hello, everyone, and welcome to Cognito Key. So let's get right into it. Have you ever really stopped to think about how your computer understands what you tell it to do? I mean, we write code using words and commands, but at their core, computers only really get one thing: numbers, zeros and ones. So how does our simple hello world become something a machine can actually execute? Let's find out. To figure out the solution, we first need to get a handle on the problem itself. And really, it's a fundamental communication barrier, a massive gap between how we think and how a computer, well, computes. So take a look at this. On one side, you've got something that makes perfect sense to us, a simple print command. But on the other side, that's what the machine's processor actually speaks, pure binary code. It's a totally different language, right? And that creates this huge disconnect. And you know what? This disconnect actually has a name. It's called the semantic gap. It's basically the huge space between our world, the application domain where we give instructions, and the computer's world, the execution domain where things actually get done. Because of this gap, our code just can't run directly on a computer. It's impossible. So, how do we cross this bridge? How do we close that semantic gap? Well, we need a special kind of translator. You can think of it as this unsung hero that works behind the scenes every single time we run a piece of code. And that hero is the language processor. Its entire job is to be our expert interpreter. It takes our source code, the stuff we write in Python or C++, and it translates it into the machine's target language. And get this, it even checks for errors along the way, which is super helpful. Okay, so we have our translator, but how does it actually do its job? It's not just some magic trick. It's actually a really methodical two-part journey that every single line of your code goes on. First up, you have the analysis phase. This is where the processor just tries to understand the source code, breaking it down to figure out what we're asking it to do. And only when it's totally sure it gets the instructions, it moves on to the synthesis phase. This is where it actually builds the new machine code version. Let's zoom in on that analysis phase for a second. Think of it like a super strict grammar teacher. First, it uses lexical rules to check if all the words, or tokens as they're called, are even valid. Then it uses syntax rules to check the grammar. Is the sentence structured correctly? And finally, it applies semantic rules to make sure each statement actually means something sensible in the context of the program. All right, so once our code gets a passing grade from that strict analysis, the synthesis phase kicks in. This is the building part of the journey. The processor starts with memory allocation, basically setting up the space and structures the program will need. And then comes the grand finale, code generation. This is where it constructs the actual binary instructions that the computer can finally understand and execute. Okay, so now that we get the process, let's meet the translators themselves. Because you see, not all language processors work in the exact same way. In fact, there are two main types you'll run into all the time: compilers and interpreters. So what's the difference? Well, a compiler is like a translator who takes an entire book, translates the whole thing at once, and then gives you the complete finished copy in the new language. An interpreter, though, is more like a live translator who sits right there with you, translating the book sentence by sentence as you're reading it. And you see this difference out in the wild all the time. Languages like C++ and Java, they're typically compiled. The whole program is translated at once into an executable file, which is why they run so incredibly fast. But then you have languages like Python. They're interpreted, translated line by line. This makes them super flexible and amazing for things like scripting and getting ideas up and running quickly. It's that classic trade-off, really, the raw speed of a compiler versus the on-the-fly flexibility of an interpreter. Okay, so you might be thinking this is all interesting, but why does it really matter? Why are we digging into this invisible process that just happens in the background? Well, it matters because these language processors are, and this is no exaggeration, the absolute foundation of everything we do with computers. They are the silent, powerful engines that let developers build all the amazing and complex apps, websites, and games we use every single day, all without having to speak in ones and zeros. Simply put, they make modern software possible. Just take a second to think about that. Without these invisible translators, what would our digital world even look like today? The entire digital landscape, everything from the phone in your hand to the massive servers that run the internet, it's all built on this fundamental, really elegant act of translation. We really hope you found this little explainer useful. If you did, do us a favor and hit that like button and maybe share it with anyone else who you think might find it interesting. And of course, don't forget to subscribe to Cognito Key so you don't miss our next deep dive into the world of tech. Thanks so much for watching, and we'll see you in the next one.